If you have your graphing calculator that will turn take your hat off, Bryce, that will turn any decimal or anything back into a fraction for you. All right. Remember the foldable that we did?
No.
Let me show you. I just saw it this morning. It looked like this. Okay, we're going to be referencing that today if you still have it. Rational exponents. Okay. The difference in what we did before and what we're doing today is today our exponents are not nice whole numbers, they're fractions. Okay? So you're going to have to add, subtract, multiply, and divide fractions. Which if you have your calculator, it'll do it for you. Okay? Alright, so let's run through them. There's 7 properties, and just quickly I'm going to go through each one. I won't put the names of them up here. What if, let's say I am multiplying and the bases are the same, what do I do with the exponents? We have that they were whole numbers, they weren't fractions. This is the only new part is now they're fractions. What do you do? Add them together, right? When you multiply and the bases are the same, you add the exponents.
What?
When you, I don't know. When you multiply with the same base, you add the exponents. So I would have, hold on a second. All right. Let's say, if you will get your calculator out with me, let's do a half. So remember, fractions always go in parentheses. And to that, we're going to add, what was the other one? 2/3. So plus 2/3. Okay. When I hit enter, though, I get a decimal. So what I want to do, I turn it back into a fraction. So if you hit the math button that says math, it's right under the second the alpha button, and hit enter, it turns it into a fraction for you. Okay?
I ain't got a calculator.
Grab one out of mine. So this becomes x to the 7/6. Okay, that's fine. Guys, if you don't have the calculator or don't want to use it for whatever reason, whatever it is, you can add these by hand, but it gets sticky because we have to do 1/2 plus 2/3. So they have to have that least common denominator, which would be 6. You multiply 2 by what to get 6? 3. So I'm going to do the same thing to the top. How about this one? What do I multiply 3 by to get 6?
2.
So do the same thing to the top. So now I combine the top over the bottom. So that's how we get 7/6. This is a lot of room to make a mistake, though, and your calculator will do it for you. All right.
Hold up, let me tell you.
Okay. If I had 7 to the 1/2 times 7 to the 1/4. Okay, so tell me what you get. What's the answer there? Let's go simplify too. 7 to the 1/2 times 7 to the 1/4. You're adding them because the bases are the same. Guys, I see a lot of us distracted by a lot of things that are not math. I need your eyeballs up here. 3/4. That's right. You add a half and a fourth, yeah.
Man, my calculator ain't give me that.
Look. 1/2, it's got to be in parentheses, plus 1/4. And then you do math, enter.
Huh?
math. Yep.
Should I calculate up on that board?
Don't combine the sevens because you don't want to combine the base and the exponents. You just do one or the other.
Hey, I got it.
Do what? No. There's 7 of these properties. We've already done them. We're just doing them with fractions now. All right, the next one. What happens if I have something to a power and then I raise it up to another power?
You gotta times it.
Then you multiply them, right? These two are multiplied. So again, I'm going to use my calculator. 1/2 times 3/4. 1/2 times 3/4. What is it? 3/8. Guys, make sure you all can get 3/8 from that. Bryce? 3/8.
That's the answer.
That's the answer.
Alright, let's just focus on this for today.
Make sure, even if it's another base here that's not x, if it was, say, 5 to the 3/5 raised to the 1/3, okay? Don't mess with the base of 5. It stays the same. The base stays the same in all of these. I multiplied 3/5 times 1/3, and you should get 1/5 if you do that on your calculator. 1/5. If you multiply it on your calculator, 3/5 and 1/3. 3/5 times 1/3. Math, enter, enter. Yes, no, maybe so? All right, let's do the next one. What happens if I have x times, actually let's do 3 times x in parentheses, and I have an exponent on the outside. I'm multiplying inside the parentheses. What happens to that exponent on the outside?
What?
It goes to both.
I thought you had to flip all these.
That's negative exponent. You're thinking when it's negative. Oh, that was solving. That we're not solving here. We're just simplifying. Only when you solve do you flip.
Alright, so if that was negative 1/2, we would flip it.
If it was negative 1/2, we're fixing to do that property. But if it was negative 1/2, you make it positive and you put it in the bottom. Negative exponent. You look at me like we've never done this before.
Look at you like you just said we don't do that. And now you want to do it.
What you're talking about is if we had x to the 2/3 equals 5, then to get x by itself, we flip this here and here. That's different because we're solving.
So we're not to write that part down?
No, that's not what we're doing right now. This is something different.
So we don't have to do that?
Only when you're getting x by itself.
So if I got x by itself, I have to do that.
Yes.
Well, the other ones we had x by itself, we have to do that.
No, when you're solving for x, getting x by itself when you're solving an equation. If you start out with an equal sign in it, that's when you do it. I'm not starting with an equal sign here on these. All right. What if I had some things here? Let's say 2 to the 1/4 times, guys, times x to the 1/2 raised to the 2/3. So what if they're in parentheses they already had some exponents hooked to them. What happens then?
Do that
You add
system.
them first. And then
I do that to both of them, but then what do I do when it goes? In other words, what's 2 to the 1/4 with the 2/3 on it? What do I do with those exponents?
add them. Add them times.
Times them. You multiply them. Because it's a power to a power. Okay? So I get 2. Now 1/4 times 2/3. 1/6. And then I have 1/2 times 2/3. Should be 1/3. Is that what y'all got?
No, I have no idea
Yeah.
which it is.
All right, guys, I need y'all up here. Cameron. Whenever I'm taking the exponent to both, I'm multiplying. This times this times this.
I thought you said when you times you gotta add.
When the bases multiply, you add if it's the same base. These aren't the same base.
Oh, only some.
Yeah. So here, I'm going to take this exponent that's on the outside. It's the same property that's in green. The difference is they already have an exponent hooked to them, so I have to take that into account. Chapter 2.
How'd you get that up there?
It's whenever we did, remember this? Yeah. What? Which one? The white? This. 1/4 times 2/3 is 1/6. 1/2 times 2/3 is 1/3. Multiply them.
Oh, so you ain't got a times that by 2.
No, leave the base alone. Don't mess with the base. All right. Guys, I know this is kind of boring because we've done it before, but I need your attention. What if this is Bryce's favorite property? What if I have a negative exponent? What do I do?
You gotta flip it.
You gotta flip it and put a 1 over it. It becomes positive and it moves.
Oh, I ain't never done that.
Yes, you have. We've done it many times. Bryce.
I ain't wrong.
What if it's in the bottom and it's negative?
Flip to the top.
Flip it to the top. Anything negative flips.
Nah, I know that. Bro, I ain't never put a fraction like that. No. That's 2 fractions on 1 fraction.
All right. What if?
Oh, whoa.
Okay. All right. Let's say that I am dividing. And I have a 1/2 exponent on the outside. What do I do? Shh, 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 guys. What do I do? What do I do?
Flip it. You distributed the x and the 5?
Yes, because if I'm multiplying or dividing on the inside, then I can distribute that exponent to both. Okay.
Equals.
No, because the bases are not the same. Okay?
Just put them on top of each other.
Oh, God. So now we divide that, right?
Nope, you leave it. You're done. Guys, I am trying to teach this to you. This is not easy. It looks easy right now, but it is not when we put it together. I need your attention. Okay? You don't have but a handful more tests in here. We're pushing through to the end. 2, 3 tops.
What else we gotta learn?
A lot. Okay. Let's say I have, and notice this time the bases are the same and I'm dividing. What do I do with the exponents?
Flip.
Subtract. Bryce, if you say flip one more time.
I'm getting confused.
Because you're trying to flip everything. The answer to everything is not flip it. Dividing means subtract, as long as the bases are the same.
Also, these were what?
1/6. These are subtracting. The exponents. A little hint as you go through some of these. Today we're focusing on multiplying and dividing and exponent properties. We're not going to talk too much about adding and subtracting until tomorrow. So, when you are multiplying and dividing, this does not work when you are adding or subtracting, so don't do that. All right, when you're multiplying or dividing, if the bases are the same, this is real important. Combine the exponents. But if the exponents are the same, you're going to ask me about this, Bryce, 100 times. If the exponents are the same, you combine the bases and leave, well, I want you to have this to remember. Leave the exponent, okay? Do not ever combine both. Never. Yes, this needs to be real big in your notes. Never combine both. I'm going to run through several examples of what your homework's going to look like.
Several. Do three. That's all we have time for.
Remember, properties of exponents can be done in whatever order you want them to do in, as long as you do legitimate properties. So here, whenever I see this, tell me what I can do. I can distribute the 10. Okay, so when I distribute the 10, I'm multiplying, right? So, okay, so we haven't got to that point yet. One property at a time. You can distribute even if the bases aren't the same. What's 1/5 times 10?
10 and 1/5.
2. Again, 1/5 times 10 is 2. Now, remember what I told you. When multiplying or dividing, if the bases are the same, combine the exponents. Are the bases the same?
No.
If the exponents are the same, combine the bases. Are the exponents the same? Yes. So combine the bases, multiplying,
You get 8.
and you get 8 to the second power.
This is
Okay? Be very careful, because some of them you may encounter might look like this. 7 to the third times 7 to the third. That's why I said never, ever, ever do both. If the base and the exponent are the same, pick which one you want to combine.
Huh?
It doesn't matter. This could be 49 to the third or 7 to the sixth. Those are the same number. Okay? But don't do 49 to the sixth. You can't do both. Let's do another.
But they don't equal the same thing.
Yeah, they will. Put them in your calculator. They'll equal the same thing.
7, 6.
You can combine the base and leave the exponent, or you can combine the exponent and leave the base, since both are the same. Look at this one. 8 to the second times 3 to the second to the negative 1/2. What can I do? I could flip it.
You gotta flip it.
What can I do now? What can I do? I can distribute. I could distribute, sure. I get 1 over. What's a half times 2? 1. Half times 2. 1.
8 times 3.
8 times 3, because the exponents are the same, I combine the bases. Leave the exponent alone. Let's try this one. This one's a little bit harder. Ah. What can I do? Somebody would say subtract. So look at that fraction. The bases are the same. What's 3/4 minus 1/2? 1/4. Now I'm multiplying and the bases are the same. So you add the exponents, combine the exponent, don't make that 25. You can't add the exponents and multiply the bases. It's one or the other. What's 1/4 plus 2? Fraction?
9 over 4.
There you go.
I'm sure you have that written down.
It's okay. Add 1/4 plus 2.
Oh, we got times that?
Yep.
So we like all that out.
Uh-huh.
5, 9, 4.
No, leave it like that. Just leave it like that. One more.
No more.
One more. What do I do?
Give up.
Somebody said flip. I could flip. This would be 1 over 11 to the 1/2 times 11 to the 5/2. When you when you multiply, you got top times top and bottom times bottom.
I thought you were doing negative.
Not necessarily. If I were doing, and I'll show you what I would have done if I was working this problem. Now subtract. You're right. So I'd get 11 to the 5 minus 4. 5 minus 1 is 4. If I were doing this one, I would have started here. Remember, there's no right or wrong order. I would have just added those two to start with, since I was multiplying with the same base. And I would have got 11 to the 4 over 2, which is 11 squared. It's not wrong. You come back to the same thing each time. I just always try to do, why does it keep doing that? Whatever makes it, whatever I think I can do in the least amount of steps is usually what I do. All right.